Good morning to you all. I am Dr. D. Hemanand, Professor from the Department of Computer Science and Engineering, SAEC Engineering College. These are the departments in our college. Now I am going to discuss about network models. Our agenda for this topic is layered task, OSI model and TCP/IP protocol suite. So first we are going to discuss about layered task. We are using the concept of layers in our daily life. As an example, let us consider two friends who are communicate with each other through the postal email. The process of sending a letter to a friend, that will be a very complex if there were no services available from the post office. The services available in the post office is the process of communicating with the two friends. Okay, that can be possible only by the services offered from the post office. In the next slide, we are going to discuss in detail about this layered task through this example. So in this diagram, you can see the sender and the receiver. Okay, there are what are all the steps involved in sending and receiving the mails through the post office? What are all the steps involved in this process? The first step, the letter is written, that should be put it in the envelope and dropped in a mailbox. Then the letter is carried from the mailbox to the post office, and then the letter is delivered to the center in the post office. That is the steps involved in the sender side. Again, after the steps completed in the sender side, the steps that is going to be begin in the receiver sides are the letter is delivered from the carrier to the post office, and then the letter is carried from the post office to the mailbox, and then letter is picked up and removed from the envelope and read. Okay, these are all the process involved in the sending a letter and receiving a letter through the post office. So the parcel, okay, that should be carried from the source to the destination. So there are, this example can be related to the layered task in the network models that we are going to see in the coming slides. Okay, this is the basic steps involved in the sending and receiving mails to the services offered from the post office. Okay, that can be related with the layered task. Okay, next slide, we are going to see about the OSI model. Okay, in the network model, okay, first we would like to see about the OSI model. The OSI model, it was established in the year 1947. The International Standards Organization is a multinational body that is dedicated to the worldwide agreement. When speaking of the internet, everyone talks about the TCP/IP protocol suite. This suite is not only the suite of protocols defined. This ISO is a multinational body that is dedicated to the worldwide agreement on international standards. Almost all the countries of the world are represented in the ISO. The ISO standard that covers all the aspects of network communication is a open system interconnection, that we call it as OSI model. It was introduced in the year 1970s. An open system is a set of protocols that allows any two different systems to communicate regardless of their underlying architecture. The purpose of the OSI model is to show how to facilitate communication between different systems without requiring the changes to the logic of the underlying hardware and the software. The OSI is not a protocol, it is a model for understanding and designing a network architecture that is flexible, robust, and interoperable. So here, this slide, we are seeing that 7 layers of the OSI model. From the bottom, we can see the physical layer, the second layer is data link, the third one is network layer, the fourth one is transport, fifth is session layer, sixth one is presentation, and last topmost is application layer. So one by one we can see in detail. So in this slide we are seeing that interaction between the layers in the OSI model. So all the 7 layers, how they are interacting with each other, from sending that information from one device to another device, how they are interaction between the 7 different layers in the ISO OSI model. So the coming slides we are going to discuss about the each and every layer. Okay, in the first we are going to see about the physical layer. So physical layer, the main functionality of this layer is to send and receive bits to and from the physical carrier, that is wire. Also this layer defines things like pinouts, electrical characteristics, modulation and encoding of data bits on carrier signal. So here in this diagram you can see that the physical layer, the zeros and ones, okay, that is bits. We are using bits of information here, that electrical conduction wire, the transmission medium, okay, that is converted into electrical signals and then pass on to the next device through the physical wire, physical transmission medium wire. So physical layer is responsible for the movements of individual bits from the one hop to the next hop. The next slide we are seeing that data link layer. The data link layer, the main functionality of this layer is to ensure the messages are delivered to the proper device on a LAN using hardware addresses and translate messages from the network layers into data frames for the physical layers to transmit. The data link layers subdivided into two sub-layers. One is logical link control, the upper sub-layer that hides the underlying network types, that is Ethernet, token ring, etc. from the network layers. And the next sub-layer is the medium access control, MAC, we can call it as the lower sub-layer controls and communicates directly with the physical network media through the network interface card. This layer converts data from into bits and vice versa. The switches and the bridges operates in this layer. The example of this data link layer is Ethernet, FDDI, Wi-Fi, frame relay, etc. So in this diagram we are seeing that the header, followed by data and then tailor informations. This is the format we are following in the data link layer. The data link layer is responsible for moving frames from one hop to the next. Here you can find the hop to hop delivery. So end system A is shown in this diagram, okay, that can be sending the information to the end system like D and F through the links, intermediate link and intermediate system. That information has to pass on to all the intermediate link and intermediate system to reach the end system D and F. So the system end system to intermediate system, we can say that is the one link. Okay, likewise we can say from intermediate system to another intermediate system, that is also we can call it as the one hop. So to reach to reach the end system from one end system, that has to communicate and pass on to all the intermediate system, okay, in between the end systems. So each the distance between the link between the intermediate system and the end system, or between two intermediate system, we can call it as the hop. So this is called as the hop to hop delivery. Next, in the slide we are seeing that network layer. Okay, what is network layer? The main functionality of this layer is to manage device addressing, to track the location of the devices on the network, and to determine the best way to move the data, which means that this layer must transport traffic between devices that are not locally attached. So routers operate in this layer. The example of this layer is IP, Internet Protocol, IPX, etc. So here in this diagram you can see that how the data packet format will be. Okay, header information and the data will be in the data packet. The network layer is responsible for the delivery of individual packets from the source host to the destination host. Next, source to destination delivery. Here you can see in the network layer the end system A, that is connected with the end system D and F, that has to pass on to all the intermediate system and intermediate links. Okay, that has to have travel the all the three layers, physical, data link and network layer, to reach the end system. So all the intermediate links and systems, it has to pass on to reach the destination. Next, transport layer. This layer segments and reassembles the data into a data stream. This layer supports connection oriented and connectionless transport layer protocol service. The main functionality of the connection oriented transport protocol is to provide reliable end-to-end data transport services by establishing the logical connection between sending and receiving host. The example for this transport layer is TCP, Transport Control Protocol, and also UDP, User Datagram Protocol. The main functionality of this connectionless transport protocol is to provide unreliable and end-to-end data transport services. Next, in this diagram, we can able to understand the reliable process-to-process delivery of a message. Okay, from one device to another device, how the messages, the process can exchange the information, the process from one end system to the process in the another end system, how they can interchange the information, so that we can call it as the process-to-process delivery. Next is session layer. Session layer, the main functionality of this layer is to set up, manage and clean up the sessions established between the presentation layer entities. Also, it ensures dialogue communication between devices by offering three modes: simplex, duplex and full duplex. The examples for this session layer is network file systems, structured query language, remote procedure call, etc. Next is presentation layer. The main functionality of this layer is to encode, decode the application layer specific data format into generic data format and vice versa. For example, if an application needs to transfer the integer value 1 at the presentation layer, the value 1 will be converted to the generic value using encoding schemes like basic encoding rule. The examples for this presentation layer is JPEG, MPEG, etc. Next is application layer. Application layer mainly used by the application programs. The main functionality of this layer is to identify the application program requested communication partner and establish the communication channel with it. For example, if the Internet Explorer application needs to upload the file to the FTP server, it connects to the FTP server through the FTP protocol. The examples are Telnet, HTTP, FTP, SNMP, SMTP, etc. So here you can see that how the application layer can be represented. So these are the summary of the layers as we discussed so far. So physical layer to transmit bits over a medium to provide mechanical and electrical specification, and data link layer to organize bits into frames to provide op-to-op delivery, network layer to move packets from source to destination to provide internetworking, the transport layer to provide reliable process to process message delivery and error recovery, the session layer to establish, manage and terminate sessions, the presentation layer to translate, encrypt and compress the data, the application layer to allow access to network resources. Next, TCP IP protocol suite. Actually, the layers in the TCP IP protocol suite do not exactly match those in the previously seen OSI model. The original TCP IP protocol suite was defined as having 4 layers: host to host network, internet, transport and application. However, when TCP IP is compared to OSI, we can say that the TCP IP protocol suite is made of 5 layers, that is physical, data link, network, transport and application layer. Here you can see the TCP IP and the OSI model. So we see the difference of TCP IP and then OSI model. So to show how the layers in the TCP IP protocol suite are involved in the communication between the two hosts. In this diagram, we can easily see that how the protocol suite are involved in the communication between the two hosts. So you can find the different layers in the TCP IP protocol suite. So the addressing is possible in this TCP IP is because of physical, logical, port and specific. The 4 levels of addresses are used in the internet. So by employing these TCP IP protocols. So these are the addresses: physical address, logical address, port address, specific address. So this is the another concept actually. You have logical communication between the pairs of layers in this model. Any communication that involves two parties needs to addresses the source address and the destination address. Okay, that is very important. And then also we look at the if you need the pairs of addresses, one pair per layer, we normally have only 4 because the physical layer does not need address. The unit of data exchange at the physical layer is a bit. So here you can see the relationship of layers and addresses in the TCP IP. So this diagram clearly depicts that the relationship of different layers in the TCP IP protocol suite and addresses in the TCP IP. The specific addresses, port addresses, logical addresses and physical addresses, how they related with each other. So the example you can clearly able to understand that a node with a physical address 10 sends a frame to the node with physical address 87. Here the 87 is available. The two nodes are connected by the link. As the figure shows, the computer with the physical address 10 is the connected with the computer with the physical address 87 is the receiver. The example 2, here you can see the most local area networks use a 48-bit, that is 6-byte physical address that can be written as 12 hexadecimal digits. Okay, it's separated by the colon. This is the example for the physical address. Otherwise, we can call it as the MAC address. So here, the another example. This example shows the part of an internet with two routers connecting three LANs. Here, LAN 1, LAN 2, LAN 3. Three LANs are there. It shows the part of an internet with two routers connecting three LANs. Each device means a computer or the router. Okay, this is router, this is the computer. This and all we can say the computer. So the previous slide we have seen each computer is connected to only one link and therefore has only one pair of address. Each router however is connected to three networks, so each router has three pairs of address and one for each connection. Here in this example it shows the two computers communicating via the internet. Sending computer is running three processes at this time with port address A, B and C. The receiving computer is running two processes at this time with port address J and K. The process A in the sending computer needs to communicate with the process J in the receiving computer. Note that the physical address changes from op to op. Logical and port address remain the same from the source to destination. The physical address will change from hop to hop. The logical address is okay. Here you can see the port address. It is a 16-bit address represented by one decimal number as shown 753. It is a 16-bit port address represented as one single number. Okay, thank you for your patient listening. Okay, in this video we have learned regarding the network model. Okay, layered task. In this network model we can able to understand the subtopics like layered task, the network models like OSI model, and then TCP/IP protocol shoot the addresses in the TCP/IP. Thank you all for your patient listening.